70 million eggs hit the road every single day. Some roll down highways in climate-controlled trucks, others fly across oceans in cargo planes, and a few even arrive by boat. But here's the real challenge. How do they survive the journey? Eggs are nature's delicate masterpieces, strong enough to hold their shape but fragile enough to shatter with a single misstep. Transporting them is a high-stakes game of precision, science, and engineering. A single crack can turn an entire shipment into a sticky, unusable mess. Yet somehow, billions of eggs arrive unscathed every year. From the moment they leave the nesting hen to the time they are cracked into a frying pan, eggs pass through a logistical ballet involving robotic arms, shock-absorbing cartons, temperature-controlled trucks, and even international air freight. Some eggs are washed and chilled, while others travel at room temperature, depending on local food safety laws. And in some cases, entire nations have to rush order emergency egg shipments by plane to keep up with demand. This is the untold story of how the world moves 70 million eggs every single day without breaking them. Before an egg ever sees the inside of a carton, it begins its journey in a place few people ever think about: massive poultry farms, where millions of hens lay eggs every single day in a perfectly choreographed cycle of efficiency. These farms operate with almost surgical precision, ensuring that eggs are collected, processed, and shipped in record time to maintain peak freshness. But this isn't just about speed. It's about handling one of the most delicate food products in the world without compromising its structure. A single crack can mean not just a wasted egg, but an entire batch contaminated and unfit for sale. So, from the moment an egg is laid, every step is meticulously designed to prevent damage while maintaining quality. The journey begins in the nesting area, where hens instinctively settle into specialized laying boxes, engineered for both comfort and practicality. These boxes have soft bedding and are slightly tilted so that once an egg is laid, gravity gently guides it onto a conveyor belt below. This is where modern egg transport begins. Not in trucks, not in supermarkets, but in the careful slope of a nesting box designed to prevent eggs from rolling too fast or colliding with one another. Conveyor belts, often running for hundreds of feet, snake through the facility, collecting eggs with a seamless motion. These belts are not simple mechanical strips. They are built with shock-absorbing materials and calibrated speeds to ensure that eggs don't bounce or jostle. In some high-tech farms, infrared cameras and robotic arms monitor the flow, automatically adjusting the speed to prevent congestion or sudden stops that could result in breakage. As the eggs move along, they approach the first critical checkpoint, the processing facility. Here, the eggs are gently ushered onto rollers that rotate them under high-intensity lights, revealing any internal defects. This process, known as candling, dates back centuries, when farmers used actual candles to check for cracks and abnormalities inside the shell. Today, industrial candling machines use powerful LED lights and high-speed cameras to scan thousands of eggs per hour, instantly detecting defects that the human eye might miss. Any egg with an irregular shell, a hairline crack, or an internal imperfection is immediately removed from the line. Some of these eggs may still be used for liquid egg products in commercial baking, while others are discarded entirely. But scanning is only the beginning. In many countries, eggs must also undergo a rigorous cleaning and sanitization process before they are approved for sale. In the United States, Japan, and parts of Asia, eggs are washed with warm water and a mild detergent to remove any dirt, bacteria, or remnants of feathers. This process, while ensuring cleanliness, also strips away the egg's natural protective coating known as the cuticle, a thin layer that prevents bacteria from penetrating the porous shell. To compensate, washed eggs are often sprayed with a thin layer of edible oil to mimic the cuticle's function and extend shelf life. However, in much of Europe and other regions, washing is avoided entirely, as many believe that preserving the cuticle provides better long-term protection. This difference explains why eggs in the US and Japan must be refrigerated, while those in European supermarkets sit safely on room temperature shelves. Once cleaned, or left unwashed, depending on the country, the eggs move to the grading and sorting phase, where they are carefully categorized by weight and size: small, medium, large, extra large, or jumbo. Every egg is precisely weighed and sorted into the correct category. This isn't just about aesthetics. Grading ensures consistency in cooking and baking. A cake recipe that calls for 2 large eggs assumes a specific weight range, and in large-scale food production, even minor variations can affect the outcome. Some eggs are even scanned for yolk color consistency, particularly in premium markets where deep golden yolks are preferred over pale ones. With sorting complete, the eggs are now ready for packaging, but this step is more critical than it seems. Transporting eggs isn't just about putting them in cartons. It's about designing the perfect shock-absorbing structure that can withstand bumpy truck rides, sudden stops, and even the turbulence of air travel. The standard egg carton, a simple yet brilliant invention by Joseph Coyle in 1911, has remained largely unchanged for over a century. It cradles each egg in an individual compartment, preventing them from touching and absorbing minor shocks. However, for large-scale shipments, eggs are often packed in pulp trays made of molded fiber, stacked in multiple layers inside reinforced crates. These trays allow for better airflow, reducing moisture buildup that could accelerate spoilage. At this stage, the eggs face their first major divergence in travel plans. Some will be loaded directly onto trucks for short-distance delivery to nearby grocery stores, bakeries, and restaurants. Others will be packed into refrigerated containers for cross-country or even international shipments. But before they leave the facility, there's one final step: stamping and traceability. Many eggs are now printed with a tiny code, often a combination of numbers and letters, that provides information about their origin, production date, and farming method. In Europe, for example, eggs are labeled with a number that tells consumers whether they came from caged hens, 3, barn-raised hens, 2, free-range farms, 1, or organic farms, 0. This system ensures transparency, allowing consumers to trace an egg back to its exact farm of origin. Some high-tech farms even use blockchain technology to provide real-time tracking, allowing buyers to scan a QR code and see the entire journey of the egg, from hen to supermarket shelf. Now securely packed, the eggs face their biggest challenge yet: surviving the road, the sea, or even the sky. Every mile brings new risks: bumpy highways, turbulent cargo holds, and customs regulations that can delay shipments. How do logistics companies ensure that fragile eggs stay fresh, unbroken, and safe to eat? The answer lies in a fascinating world of climate-controlled trucks, specialized shipping techniques, and emergency airlifts that keep the global egg supply running smoothly. Eggs are nature's paradox, structurally strong yet incredibly fragile. Transporting them without breakage requires careful engineering, from shock-absorbing cartons to climate-controlled storage. Without proper packaging, the 70 million eggs shipped daily across the world would become a scrambled mess before they ever reached a kitchen. The modern egg carton, first invented in 1911, may seem simple, but it's a carefully crafted tool to minimize movement and cushion eggs from impact. Most eggs are packed in one of 3 materials: pulp fiber trays, polystyrene foam, or PET plastic. Whether cradled in pulp trays, cushioned in foam, or packed in plastic, every egg container is designed with one mission: prevent movement. Bulk shipments are stacked in ventilated crates, wrapped tightly to avoid shifting, and handled with robotic precision. But even the best packaging can't stop the invisible enemy: temperature changes. For large-scale shipments, eggs are placed in bulk trays holding 30 eggs per layer. These trays are stacked inside ventilated crates or pallets, wrapped securely to prevent shifting. In high-tech distribution centers, robotic arms handle eggs with pinpoint accuracy, reducing human error and minimizing breakage rates. Beyond physical protection, temperature regulation plays a critical role in egg transport. Since eggshells are porous, improper storage can cause condensation, creating a breeding ground for bacteria like Salmonella. This is why storage requirements vary across the world. In North America, Japan, and parts of Asia, eggs are washed and refrigerated from farm to store, typically kept at 1 degree Celsius to 4 degrees Celsius, 34 to 39 degrees Fahrenheit. In Europe, Australia, and many other regions, eggs remain unwashed and are stored at room temperature around 20 degrees Celsius, 68 degrees Fahrenheit. This difference complicates international transport. If a refrigerated egg warms up, condensation forms, increasing contamination risks. Conversely, sudden cooling can cause microcracks in unwashed eggs. Transporters must carefully monitor temperature transitions to prevent spoilage. To further reduce damage, the egg industry is developing shock-resistant cartons, IoT-enabled tracking systems for real-time freshness monitoring, and even self-healing packaging that absorbs small impacts. Some major distributors have already cut breakage rates by 30% simply by switching to reinforced bulk trays. But even with perfect packaging, the real challenge lies ahead. Eggs must now travel thousands of miles by truck, ship, or plane, each mode of transport presenting unique risks. How do eggs survive these unpredictable journeys without cracking? That's where the next phase of logistics comes into play. Once eggs are packaged, their real test begins. Every day, millions of eggs travel across highways, navigate turbulent seas, and even fly across continents, all without cracking. But ensuring their safe passage is no small feat. Unlike other food products, eggs cannot be stacked too high, exposed to rapid temperature shifts, or handled roughly. One wrong move, and entire shipments can be ruined. For most eggs, the journey starts on refrigerated trucks bound for supermarkets, restaurants, and food processing plants. These trucks, designed for temperature-sensitive cargo, maintain a stable environment of 1 degree Celsius to 4 degrees Celsius, 34 to 39 degrees Fahrenheit, in refrigerated regions or room temperature for unwashed eggs. But it's not just temperature that matters. Shock absorption is critical. Egg crates are carefully loaded to prevent movement during transit. Drivers avoid sudden braking and rough roads, as even minor jolts can cause hairline cracks. Some trucks use air suspension systems, which absorb vibrations, while others employ automated load stabilization technology that adjusts crate positioning in real time. Eggs traveling internationally often cross oceans in climate-controlled shipping containers. These containers are insulated and monitored to ensure that temperature and humidity remain stable. Because ships can face rough seas, egg shipments are secured with anti-slip mats and shock-absorbing pallets. However, sea transport comes with one major challenge: time. Unlike trucks that deliver eggs within hours or days, ocean shipping can take weeks. To extend shelf life, eggs shipped this way are often coated in a protective layer of oil to reduce moisture loss and bacterial contamination. Surprisingly, some eggs travel by plane, particularly for urgent deliveries or luxury markets. High-end restaurants in Asia sometimes import specialty eggs from Europe or the famous Japanese Jidori eggs prized for their deep yellow yolks. But air transport is expensive, requiring strict handling protocols. Cabin pressure changes can sometimes cause eggs to develop tiny internal cracks, which is why specially reinforced packaging is used for air shipments. Additionally, flight temperature regulations must align with the egg's origin. Chilled eggs must remain cold, while unwashed eggs must not be exposed to refrigeration. International egg transport must also navigate complex food safety regulations. Some countries ban imports of washed eggs due to concerns over shell integrity, while others prohibit unwashed eggs for bacterial safety reasons. Additionally, eggs must clear customs inspections, where authorities check for compliance with temperature, packaging, and contamination standards. With so many obstacles, how do eggs consistently arrive fresh and intact? The answer lies in a blend of logistical precision, advanced technology, and careful human oversight. But even with these innovations, one final challenge remains: ensuring eggs reach store shelves before they expire. The final stage of their journey is all about speed, efficiency, and getting them into consumer hands before time runs out. After surviving farms, packaging, and long-distance transport, eggs enter their final stage: distribution to stores and restaurants. But even here, time is critical. Unlike frozen foods, eggs have a limited shelf life, meaning they must move quickly from warehouses to store shelves while staying fresh and unbroken. Before reaching stores, eggs are held in distribution centers for sorting and temporary storage. In refrigerated markets like the US and Japan, warehouses maintain temperatures of 1 degree Celsius to 4 degrees Celsius, 34 to 39 degrees Fahrenheit, while in regions where eggs are sold unwashed, they are stored at room temperature, 15 to 20 degrees Celsius or 59 to 68 degrees Fahrenheit. To prevent spoilage, eggs follow a strict first-in, first-out system, ensuring that older stock is shipped first. Most eggs spend no more than 48 hours in distribution before heading to supermarkets, restaurants, and bakeries. Once in supermarkets, eggs require careful handling to avoid breakage and maintain freshness. Stores restock eggs multiple times per week and position them in temperature-stable areas to prevent condensation or spoilage. Retailers also use clear plastic cartons to let consumers inspect eggs without opening the box, reducing waste. Meanwhile, discounts on near-expiry eggs help minimize losses. Despite weeks of careful transport, an egg's fate often depends on its final handler, the consumer. Rough handling, sudden drops, or exposure to heat during transport can undo weeks of careful logistics. To help prevent this, grocery delivery services use insulated packaging, while some brands now offer reinforced cartons to reduce breakage at home. And yet, despite all these challenges, billions of eggs reach kitchens intact every year, a testament to the precision, innovation, and effort behind one of the world's most fragile foods. Every egg on a breakfast plate has traveled an extraordinary path, beginning in a poultry farm, passing through high-speed sorting lines, surviving long-distance transport, and finally landing in a kitchen unbroken. What seems like a simple grocery item is actually the result of precision engineering, global logistics, and careful handling at every stage. From shock-absorbing cartons to climate-controlled trucks, moving eggs is a delicate science, balancing speed, efficiency, and food safety. Innovations like IoT-enabled tracking, robotic packing systems, and advanced packaging materials continue to push the industry forward, reducing waste and breakage. And yet, despite all this technology, the final moments of an egg's journey, when a consumer carries it home, remain the most unpredictable. The next time you crack an egg into a pan, think of the hands, machines, and miles that carried it safely to you. What seems like an everyday item is, in reality, a triumph of logistics, where precision meets fragility and where millions of eggs make an impossible journey every single day.